Before we start discussing CPU scheduling, imagine three different scenarios. First, a cricket stadium. Then we'll talk about our university administration office and then our computer science department. At first, these three places appear completely unrelated. But if we observe closely, we will discover that all three depend heavily on scheduling decisions. Let us begin with cricket. Recall the ICC T20 World Cup semi-final between India and England. World Cup 2026. The match has reached the 17th over. Only 3 overs remain. The batting team still has powerful hitters. The entire stadium is intense. The captain of India, Surya Kumar Yadav, is standing near the pitch thinking deeply. He asks himself three questions. Who should bowl the 18th over, followed by the 19th over and 20th over? He evaluates two key bowlers, Jasprit Bumrah and Hardik Pandya. Bumrah is extremely accurate and can control runs. Hardik Pandya can confuse the batter with slower balls. So the captain schedules Bumrah for the 18th over and then he schedules Hardik Pandya for the 19th over. Each decision is based on strategy, performance, and timing. Now let us take another example of university. Imagine our SPPU examination department. There are thousands of answer sheets arrive for evaluation. Some of them are MCA papers, some of them are MSc papers, engineering papers, some of them belong to backlog examinations. The examination unit must decide now which paper should be evaluated first, which department should receive which bundle, which evaluator should handle which subject. And this is what the scheduling problem. Let me address the third example. Like at PUCSD, when new academic year begins, for example, our batch 2025 students will be assigned some responsibilities by forming different cells like placement cell, CSFG, alumni cell. The department must decide now which students will be assigned to which cell, who should be the faculty coordinator, how many members each cell should have, which students are suitable for the technical roles. This again is a form of scheduling and resource allocation. Think about your computer now. Multiple programs want to run. Your browser, your compiler, your music player, your background OS process. But the CPU can execute only one instruction at a time. So the operating system must decide which process runs first, which process runs next, which process must wait. And this process is called as CPU scheduling. CPU scheduling is one of the most important responsibilities of an operating system. To understand this concept, imagine a busy airport. Many airplanes are waiting to land or take off. But there are only few runways. An air traffic controller must decide which plane lands first, which planes must wait, which plane must take off next. Similarly, inside a computer, many programs want to make use of the CPU. The CPU scheduler acts like an air traffic controller. It ensures fair and efficient access to the CPU. Let us connect this with our earlier examples. In cricket, we saw the captain decides the order of bowlers. In SPPU examination unit, director of examination and examination team will be deciding the order of paper evaluation. In PUCSD, the faculty will decide how the students from batch 25 would be distributed across various cells. Similarly, the operating system decides the order in which processes will execute. And this coordination allows the computer to appear as if many tasks are happening simultaneously. Now, why CPU scheduling is essential for multitasking? Modern computing systems rely heavily on multitasking. Think about a typical situation on your laptop. You may be watching a recorded lecture like this one, editing a programming assignment, downloading a research paper, listening to music, running in background, probably a virus scan, all at the same time. However, the CPU cannot execute multiple instructions simultaneously. Instead, it executes tasks one by one extremely and very quickly. CPU scheduling creates the illusion that all tasks are running simultaneously. Without scheduling, several problems would occur, and one process might monopolize the CPU. Other programs might become unresponsive. The system performance would degrade. So CPU scheduling ensures several goals. Responsiveness, so users experience quick interaction. Throughput, so many processes complete within short time. Low waiting time, so many processes do not stay idle in queues. Fairness, so that all processes receive CPU access. The scheduler silently manages these tasks thousands of times per second, and that's why we call it as an unsung hero for multitasking efficiency. Let us try to understand how exactly the decision is made. Operating systems do not rely on single scheduler. Instead, they use three types of schedulers: long-term scheduler, medium-term scheduler, and short-term scheduler. These schedulers operate at different levels. To understand this better, let us use the university analogy, which we addressed earlier. Let me consider now long-term scheduler to be behaving like an SPPU admission office, the PG admission section. It decides which students are admitted into the university. The medium-term scheduler behaves like an administration office, managing student transfers or temporary academic breaks. And the short-term scheduler behaves like a teacher, choosing which students answers the next question in the class. Similarly, in cricket, team selectors decide the squad, coaches plan the strategy, and captain decides who bowls the next over. Each decision happen at a different level. Now let us understand each of these schedulers one by one. Let us understand first the long-term scheduler. The long-term scheduler is also known as a job scheduler. Its main responsibility is deciding which process enter in the system. It selects from the job pool and loads them into the memory. This decision determines the degree of multiprogramming, which refers to the number of processes in memory. If too many processes enter the memory, the system becomes overloaded. And if too few processes enter the memory, the CPU remains idle. Therefore, the long-term scheduler must maintain the balance. It also ensures a mixture of CPU-bound processes performing heavy computation, IO-bound processes performing IO operations, and this balance keeps both the CPU and IO devices busy. Imagine again, SPPU Examination Unit assigning answer sheet bundles. If all evaluators receive difficult papers simultaneously, evaluation slows down. And if papers are distributed strategically, work progresses efficiently. Now let us understand the medium-term scheduler. The medium-term scheduler is responsible for managing memory. It temporarily removes some process from main memory when memory becomes crowded. And this process is called as swapping. Swapping means moving processes to the secondary storage. Later, when memory becomes available, the processes return to memory. Let us use PUCSD student cell example. Suppose the placement cell initially includes 20 students. Later, the faculty coordinator realizes that the cell has too many members. Some students are temporarily reassigned to other cells. Later, they may return as and when required. Similarly, the medium-term scheduler temporarily removes processes and brings them back later. And this mechanism helps preventing the thrashing. Thrashing occurs when the system spends more time swapping processes than executing them. Now let us understand the short-term scheduler. The short-term scheduler is most active scheduler. It selects next process from the ready queue and allocates the CPU. This decision occurs extremely frequently, sometimes every few milliseconds. Let me take again the example of cricket that we had earlier. The captain decides that Bumrah bowls the 18th over, Hardik Pandya bowls 19th over. These decisions happens quickly and dynamically. Similarly, a short-term scheduler rapidly selects the processes. It uses scheduling algorithm, which we would be talking later, such as first come first serve, shortage job next, round robin, priority scheduling, and these algorithms decide or determine which process should run next. Now let us understand the flow of process execution. How these schedulers cooperate. Processes initially reside in the job pool. The long-term scheduler selects processes and loads them into memory. And these processes enter the ready queue. The short-term scheduler selects one process to run on the CPU. While executing the processes, make complete execution. Request input output operations. Return to ready queue. May be suspended by the medium-term scheduler. Later, the suspended process may return to the memory and continue execution. This coordinated movement ensures smooth system operation. Let me go back to our earlier example of university campus. The long-term scheduler acts like the admission office selecting students. The ready queue acts like the student lounge where students are waiting. The short-term scheduler acts like a professor calling students to participate in the class. The medium-term scheduler acts like the dean allowing temporary academic leave or exchange programs. This analogy will help you to visualize how processes move through the operating system. Now, most important part of this CPU scheduling. CPU scheduling aims to optimize several performance metrics. CPU utilization should remain high so the processor remains productive. Throughput should increase, meaning more processes finish execution per unit time. Turnaround time should decrease, meaning processes complete faster. Waiting time should decrease, meaning processes spend less time waiting in queues. Response time should be small, so interactive systems feel responsive. For example, when students check results on the SPPU examination portal, they expect quick responses. Efficient scheduling ensures this experience. And let us conclude now. Let us return again back to the cricket match. The captain carefully scheduled bowlers. Bumrah controlled the 18th over, Hardik Pandya bowled the 19th over. Strategic scheduling helped India maintain control of the match. Similarly, inside your computer, similar scheduling decisions occur every millisecond. Long-term scheduler decides which jobs enter the system. The medium-term scheduler manages memory. The short-term scheduler allocates CPU time, and together they create the invisible choreography that allows your computer to work in multitasking mode smoothly. Understanding these processes, this process exactly, reveals the elegance and intelligence behind operating system. And that concludes our journey into the fascinating world of CPU scheduling. Thank you.